G'day, I'm Pete and you're watching Feral Fabrications. We're doing a complete tangent from race car builds and we are going to make a wee metal foundry. Hope you enjoy this one. I was actually really surprised how easy it was. Only took like a couple of nights, so it's cool.
Right, so making this foundry, probably the most difficult thing is just getting the materials up front. You can't use regular old Portland cement because it can't withstand the heat. So I managed to find some calcium aluminate cement being sold on Trade Me in New Zealand, and that can withstand much higher temperatures, so that's what I've managed to get for this project. The other thing is some fire brick mix aggregate, and I'll be mixing the two things together. Now, I wasn't too sure what ratio to go for the mixes, so I tested out 1/4, 1/3 and 1/2. Okay, so we've got our samples done. So that was the 50-50 mix, the 1/3 and the 1/4. Now I've got to say the 1/4 just seems a little bit crumbly. I don't think there's quite enough cement in that, so I think we're going to put that to the side and say no to that one. And that leaves the 50-50 and the third. I'm quite liking the third. The 50-50, I remember when I was making it, it was like almost like there was just too much of this stuff. Kind of went sort of spongy and a bit weird, like didn't have enough substance to it. So I'm sort of thinking that this might be too much cement, and I'm leaning towards this. Now this has got a few sort of loose bits on it, but the actual piece itself isn't real crumbly. I'm going to hit these with a bit of heat and see what they do just before I make my mind up. I noticed that was sort of crackling and popping a little bit, and I can only really put that down to the castings not being fully cured because I'd only done them the night before. But I thought I'd move on to the 50-50 and see how that fared anyway and just pick the best one. So I do hope that this withstands heat better than that in the long run. I think it's just because of the moisture on that really green casting. But even so, I think we've still got our winner with the 50-50 ratio. It just stood up to the heat a bit better. Right, this is what we're planning on doing for this little foundry. Stainless steel bucket, bought it from Bunnings, 18 litre, so pretty decent size. Pretty big pot plant. And I also picked that one because of that pattern on the bottom, just to lift the crucible up off the bottom a bit. So I quite like that feature of that. It's about 1 inch all the way around, which isn't a lot, but it is pretty similar to like fire bricks in your fire. So while this thing will probably put out some heat, I'm still confident it'll melt aluminium. So that's what I'm going for the foundry. Let's mix up some 50-50 mix of this stuff. We'll put it on the bottom first and then probably start packing it around the sides of the bucket. Okay, here's our first batch. Maybe a tad wet, could have probably got it slightly dry, but at least with it being slightly wet, this bottom piece, it should form to the bottom of the bucket. So let's just put this in the stainless bucket and see if we've got enough. Right, I think we can go for a little bit more than that in the bottom of there, so we'll mix up another batch. I'll put a bit more on the bottom, put some in the bottom of the bucket, and then put our formwork in, and then we can start packing around it up to the level we want. Right, there we have the finished product. Reasonably happy with it. Got that fill up with water and a brick in there, just weighing it down, because it obviously tries to float after a bit there, so... But given the whole thing a good wiggle, it's got everything nice and even and smooth and settled everything down. Like I don't think I'll have many air bubbles or anything in there. So
Okay, well, not much else to do now except let it dry. Right, I've just come down to pop this out in the sun. I thought it'd help it dry out. But what's crazy is how warm this has gotten. Like, if I touch it down the bottom, I can only just touch that. That's how hot it is. I wouldn't be surprised if it's like, hasn't really warmed up the water on that just because of the plastic bucket. But that is hot. I seriously couldn't leave my hand on that. So that's crazy that cement's doing that. But definitely means we're getting a pretty good reaction there. So that's cool. All right, here's the moment of truth. Managed to work it loose with the pliers. I haven't looked down the bottom yet. How'd we go? Oh, that's not bad. That is not bad, you know. Pretty happy with that. Okay, now I've found the perfect size bucket for my lid. Don't tell the wife. But I've made up this frame so that if the lid cracks, hopefully it doesn't just all fall apart. And just to mount the handles off as well to lift the lid on and off. And hole in the centre for when it's running, about 3 inches or so, should be plenty. Let's get underway and we'll whip that up now. A fair bit of air out of it. Don't want too much air out of it though. Air's not really a particularly bad thing with this, I don't think. Right, so we've got our lid all done with handles. It's looking pretty good. And the next thing is we've got this flamethrower. So it's pretty cheap and nasty, very Chinese. Probably costs about 30 bucks or something. Not sure if it's going to do the job, to be honest. It's sort of got like this fully open position here to really let it rip, which would just be using all of the time. But we might just be able to, like, you know, put a packer and a nut in or something there. Not too sure. Or maybe it'll be handy and we'll just make a little clamp or something to lock that off when we want it going full bore. So that is what we've got. And of course we need to put a hole through the side of our foundry to get that to work. Now, I'm not going to put it all the way at the bottom. I'm actually going to lift it up a bit. That way, if the crucible fails or whatever, all of the liquid metal isn't going to fall out onto the ground. So we'll probably just, you know, put it up a bit and just angle it down in there, just to point the heat down onto the bottom. Then have all the flames sort of swirl back up high after that. So that's kind of the plan. I'm going to mark out a hole and get cutting. Okay, here we are, finished product. Got the hole punched through the side. How I went about it was attacked with the angle grinder first. Then got the masonry drill bits, drilled a bunch of holes around the outside, punched the concrete out. Then actually used a die grinder bit, not that exact one, but used a die grinder burr to just enlarge the hole and get everything fitting nice and snug. So if we have a look on the inside, see how it come out like. It's looking pretty good. Once I get this thing fired up, I may just trim that off on a bit of a 30-degree angle just to get the flame spinning around the crucible nicely, but I want to get it fired up before I do that. And that's our finished lid. Remember, we made that sort of metal bit to go inside it and all of that, so it came out pretty nice. Now the only thing I would do is, I'll show you what I mean. What I would do is change the height of the handles. If those handles were slightly lower, I could lift that up on the bucket, and that's a good sturdy handle, and I could pick the entire thing up, shift it around. But as it is, I have to take the lid off and then move the bucket and then put the lid back on, so that's a little annoying. So I will change that, but for now I'm going to call it, because this needs to cure up for, you know, quite a few weeks. I'd leave it at least 10 days to dry out before you fire it, because you've got to make sure it's nice and dry, otherwise the water in the refractory will try escape as steam and split it apart and crack it. So there's no point rushing the first firing of it. We want it to sit and cure, get as much water out of it as possible. The other thing I'm going to do before I fire it is replace that gas hose. It's very Chinese and I don't really trust it. and I think these have to be hooked up straight to the gas bottle with no regulator, so it needs to be able to take about 150 psi at least. I might try a regulator first and see if it's got enough grunt, enough gas flow. If it does, great. If not, we'll just hook it straight up to the bottle and do it that way. So there we have it, the foundry's all finished. Just got to let it cure up, whip up a crucible and change that gas line on that blowtorch, and then we'll be ready to see if we can melt something. Looking forward to that. So, hope you enjoyed it. Bit of a tangent from the usual race car build stuff, but I'm going to actually be using this to eventually make some really cool race car parts, hopefully. You will be amazed at how long-winded the process of building this through to the finished race car part will be, because not only do we have to make a foundry, we have to machine some stuff with this melted aluminium we make with that, and then that forms a part of another tool we'll actually use to make the race car parts. So really long-winded. But hey, I thought this kind of stuff's pretty interesting, and being able to melt down aluminium and do some basic casting would be really handy. So thanks a lot for watching, hope you enjoyed, and we'll see you on the next one.